Hi friends, in the last video we learned the types of work. That is, in the last video we learned work done against the force or the negative work done. Another one important part is here, that is the no work force. This is very important. This concept is very important. No workforce. No workforce, or this is also called null work done or zero work done. This is also called null work done or zero work done. What happens if we push the wall? We are pushing the wall, but the wall does not displace at all. All the planets move round the sun, but they does not do, each planet does not do any work against the centripetal force of the sun, against the centripetal force of the sun. Similarly, if the potters carry load on their head, then what happens? Then the potters does not do any work against the gravity. How can we explain this? Let us consider the work done mathematically, that is FD cos theta. FD cos theta. If cos theta becomes 0, cos theta becomes 0 if case 1, if cos theta this is equal 0, the work done FD this will be 0, and this is possible only when cos 0 degree, cos theta equal 0 degree, that means 90 degree, cos 90 degree 0, therefore we say that theta equal 90 degree. If the theta, the force of the displacement suffered by a body takes place perpendicularly with the action of the force, that means F and D are perpendicular, then the no work is said to be done. This is happen only in case of few examples like this. Let this is be the sun and the planet revolve around the sun. This is the sun and this is the planet, P for planet. Now the centripetal force acts towards this, that is the centripetal force. Centripetal force, but the direction of displacement of the planet at that instant in the motion around the sun, that will be the direction of the displacement of the planet at that instant. Let the instant be A at that instant. So they are perpendicular to each other. So against the centripetal force, this planet does not do any work because the theta equal, this theta equal 90 degree. Similarly, if the potters carry load on their head, when the potters carry load on their head, he does not do any work against the gravity because the W equal mg, mg acts in this direction and the displacement suffered by the potter in this direction, they are perpendicular to each other, they are perpendicular. That's why potters does not do any work against the gravity when he carries load on their head. Another one possibility is if we apply the force but the body does not suffer any displacement, if B equals 0, then what happen? Then there will be work done 0 because W equal FD cos theta, FD cos theta, since this is equal 0, since D equals 0, so work done will be 0. This is the no work force. But here we learn the types of work, but first we have to learn the units. What will be the unit, what will be the dimension of it. Let us see the dimension of the work. Work is a scalar quantity, which is the combination of the dot product of two vectors, force and displacement. So what will be the dimension? Very sincere, the dimension of the work. Dimension will be the dimension of the force mlt to the power minus 2 into displacement. So this will be ml square t to the power minus 2. And what will be the unit? Units of work. Units of work. Units of work. There are two systems, in absolute and in the gravitational. Generally we use the term absolute unit, but we learn both of them. Absolute unit of work in SI or MKS, SI or MKS, that will be Newton meter. This is equal joule. This is equal joule, simply represented by J. And in CGS this will be dyne centimeter. Dyne is the unit of force and centimeter. dyne centimeter, this is equal arc, ERG, simply ERG. And in FPS, not necessary, but we learn here that will be poundal foot, not important, poundal foot. Similarly, in the gravitational system of unit, in gravitational unit, here also in SI, that will be kilogram meter. In CGS, not necessary, that will be gram centimeter. And in FPS, this will be pound foot, okay. There will be standard relation like all other physical quantities between the units of work done also here. 1 joule, this is equal 10 to the power 7 watt. Now we learn this 1 joule, what is the relation between them, that is the standard relation between them. 1 joule relation between them, relation 1 joule, this is equal 1 newton into 1 meter, 1 newton into 1 meter, this is equal 1 newton equal 10 to the power 5 dyne. Let us see 1 newton equal 10 to the power 5 dyne, we learned in the previous video, force and motion. And 1 meter equal 100 centimeter. So we can write this 10 to the power 7 dyne centimeter, simply that is 10 to the power 7 arc. Also we learn this by the dimensional analysis, we can establish the relation between the joule and arc. But if we do some work with respect to time, we can calculate this, how much work is done by a body with respect to the time. Let us consider a body does some work in time t. In time t, the body does some work. The work, let this is be W. W be the work done. So if we calculate the rate of work done with respect to time, then this will be power. This will be power. This is denoted by power P. This is equal in 1 second or in unit time, the work done will be W by T. Work done will be W divided by T mathematically. In T time, W work has said to be done, and in unit time, W by T. This is called power. So power equal work done W by time T. How much amount of work said to be done in the unit time? This is called the power. Mathematically also, this is a physical quantity, and we can calculate the dimension of the power and also the unit of the power and the relation between them. This is very important for the dimension. For the dimension of power, here we write dimension of the power denoted by capital P. This is equal the dimension of work done m L square T to the power minus 2. This is divided by T. This is divided by T. This is equal m L square T to the power minus 3. This is the dimension of the power, and this power can be expressed with the other some physical quantities related to them. Let this is be very important for the exam and also for the different competitive exam. This relation is very important. Power P, this is equal work done, work by time. If we write this, the work done, this is equal force into displacement, divided by time. Now we arrange them in such a way, this is equal force into displacement by time, So this will be force into displacement by time. This is called velocity. Displacement by time, this is equal velocity. So the power P equal force into velocity. Power P equal force into velocity. This is very important. This is very important reduced relation between the power and the force. Units of power, work done by time, joule by second. that is called watt. Similarly, arc by second. Similarly, the poundal foot by second. These are the 3 units of power, and also some other relation are here. We'll learn in the next video. Today up to this. Okay.